it's Gaming here from Learn Python with Gaming, and in this video, we will be talking about operators in Python. As you can see here, I have a file already open with some variables already assigned. So, first variable I have here is result, and this is where we test all our results. And then down here, it's printed, so we see the result of our results or the return value that comes out of the operator. So, what are operators basically? Operators are operations are used to perform operations in Python, and these operations return values, always return values. And there are about seven types of operators. We have the arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and wise operators. So I'm going to take about only three examples from each of them. So there is salt, and we say we use addition. So the arithmetic operators involves there are about there are different types of it. That is addition, subtraction, multiplication, um, modulus, floor division, and exponentiation. So we're just going to work with addition, subtraction, and multiplication. Two results plus is 2 plus, like I said, is used as an arithmetic operator. So it's going to bring out a result which is 2 plus 2, 4. So you can also change inside here as a 2 minus 2, 0. And multiplicate 4. And then you can also divide. Let's say 5 divided by 2, 2.5. Now we have floor division. Now if 5 divided by 5, this is the symbol for floor division, division signs. So you see 2. So floor division turns the result into a whole numeral. Like even though you had 10 divided by no floor division, just divided by 2. Normally to give you 5, but to give you 5.1. But if you are working on something and we don't need to be in a kind of float format, we need it to be whole 5. Okay. So we also have modulus. Now modulus simply returns 0 if there is 0 if there is a remainder, and 1 um 0 if there is no remainder, and 1 if there is a remainder. 10 divided by 2, there is no remainder, to 0. But if 5 divided by 2, there is a remainder, so it's going to give us 1. And then exponentiation is the raised to power. So 5 raised to power 2 is 25. You see, simple. So just like that, we are done with arithmetic operators in Python, and we move on to the next operators, assignment operators. I said I'll take about 3 examples. I took more than 3 in the arithmetic. So in the first, this assignment operators, we have different types of assignment operators. Over here in the, we have about, there are a lot of them. We have um sorry, yes, the assignment operators equal to, this is used to assign like variable, like x is the variable, 5 is the value. So result, and this is an assignment operator assigning the result to um hello. Now we just assign it to hello. If we print out, it gives hello. And then also we have, can also assign it to a number 23 or a float too. Okay. So can also do the what we are doing, we are adding 23 to result. That means result is already there. So the x plus equals to 23 is also the same thing as x equals result, sorry, equals to result plus 3. So this is just a shorter way of saying it. You can say, and it will give us 23. Now you will not get it now, but let's say up here we change this result to kind of like give us 5. Okay, the 28 because 23, that is this 5 plus 23. The same goes for the result minus 23. Let's say we had 40 and let's change it to 20. You know the answer will be 20. So we are doing result minus 20. There are still a lot. We still have multiplication, modulus, third division, they all work the same way. You can go to W3 school and you see them. So some of the websites is wschools.com. So just go there, you see, check on the operators, Python side, you see different operators. And then we move on to the next operator on our list, which is comparison operators. Now, these operators are wonderful. These operators, what they actually do, so the next operator on our list, the assignment operator. Now, the comparison operator. Now, the comparison operator, let's say we have dot, dot equals to 0. So let's go back to that website I was telling you about, comparison of. So let's let's create another variable. Let's assign, let's say, new var. Let's create new var equals, let's use a string and let's say hello. So true. So why is this result true? Because it compares new var and hello, and it finds out that the value of new var is hello, and so is the, so it gives us true. But let's say we had hello, okay, so false, because hello and hell no are not the same. Just, and then next in the comparison operator we have not equal to. Get the sense of that. If you change this not equals to true, but if false, because they are equals. No, just get that. Then we have greater than, whether this is greater than this. That is when you have numbers. Let's say x is 5, this is 10. And then you now have less than or equal to, get those. Then we move on to the next operator, the logical operator, which uses and or not. So it can be like dot equals to, let's say we had 5 greater than 3 and 5 less than, enter the result true. But if we said 5 is less than 3, false. But then if we change this to or, get true. Do you know why? Because and means, when you said and, Because when we said and, we meant these two must be the same. 5 and like 5 is greater than 3 and 5 is less than 3 must be true before it prints out true. But when we said or, means any of them can be true. So get it, that's what a logical operator is. Then we have not. So now from here, the description sef returns true if both statements are true and returns true if one of the statements are true, while dis reverse the result and returns false if the result is true. So let's say we had return true for us, but it did not, instead of giving us true, gave us false. And then let's say change this and change it, and then instead of giving us, okay, this give us true, and then if we changed this to 3, sorry, it will give us true. But in the other time, the other one, it gave us false. But now it will give us, so you get it, it just reverses whatever is supposed to happen. If this is supposed to, this ordinary is supposed to give us true, this not, it will give us false. So you can also be like, let's say new var not hello. So it, this okay is, now this, there's a difference between is, that this, and sorry, and this. If you get what I mean, that is like, is used in, is used in, like, is used in, okay, we'll get to that later. We'll get to that later in other videos in the identity operators. So let's move on. So identity operators, now what they do is they return true if both variables are the same object, and returns true if both variables are not the same, and it returns true if both variables are not the same object. Let's say we had new var and we had var and had, we are both hello. So we can be like, you see, new var is var, true, because they are both hello. But if you say new var is not var, false, because they are both the same. But if you change this to hell no, run it again, get true, because they are not the same. So that is under the comparison operators. That under comparison for itself. So this is under the identity itself, the identity operators. Is not under identity operators, then this, then under logical operators we have and or not. And then we move on to the next one, second to the last, membership operators, which deals with in and not in. So returns true if a sequence with specified value is present. Let's say var is hell no. So we say n in var. That means the letter n in var. If we run the true, because no, see no start with an n. So if we say f in var have false. Same if you have a list of numbers, so let's say an array of numbers, let's say we turn this new var into an array of numbers that has to be 1, 2, 10, 5, and then we are like turn this new and change it to 4. 4 is not in that array of numbers, so false. But 26 is there, true. So you get it. That's how it works. That is under the membership operators, and not in is when it's not in. So we all get that. We worked on that. And then the bitwise operator. Now these are used to compare binary numbers to set each bit to 1 if both bits are 1. So we can be like I think I do dot equals to, so result equals, let's say, 1 and 0. 0. What did it say here? It said set each bit to 1 if both bits are 1. But if they are not, it keeps it at 0. So 1 and 1, 1. So we have or set each bit to 1 if one bits are 1, if one of the bits are 1. So sorry, but let's see. Now let's change 0 gives us 0. So you get the idea. Just read through here. X or like store. Set each bit to 1 if only one of the bits is 1. Invert all the bits. So let's say we had 1, that's a not. I don't think I pretty know how to do that one well. Okay, invert all of them. So it's like a -1. Sorry. And that's all we have for today. I hope you enjoyed and learned a lot from this video, which I talked of the different operators and give examples. For more info on these operators, you can go to www.schools.com, where I got the examples from, got the examples from W school, and you can also I also have somewhere you can try it out. So that's all we have for today. Keep learning. Have a nice day.